good. All right, so chapter 1-3, we're going to be talking about properties of addition and multiplication. And we're going to do a little bit of review from 1-1 and 1-2, and then that should get everybody ready for the quiz that we have tomorrow. All right, so the first thing we want to look at is we want to look at different properties, and the explanation is using variables. Okay, so a plus b is the same as b plus a, or equals when I say it's the same as. So if you plug any number in for a and put it on both sides of the equation, and you plug in any number for b and you put it on both sides of the equation, it's going to make an example of the property. So this is the commutative property of addition. And what that means, it says there, a plus b equals b plus a. So let's pick any number for a. Somebody give me a number. I don't care what it is. What is it?
B.
No, I need a number
Oh.
for A.
5.
5. Okay. And then Briley, I'll have you. So for A, we're going to use a 5, right? So a 5 and a 5. And then Briley, give me a number for B. 6. All right. So what this means, if you go over here to the example, is that 5 plus 6 equals 6 plus 5. Okay. So write that in your example box. And then let's test it. Let's work out, or let's solve or evaluate both sides. 5 plus 6 is 11 equals 6 plus 5 is 11. So does this commutative property hold true? Okay, so basically what this means in addition is the order doesn't matter. Okay, and that's called the commutative property. Commutative property of multiplication is basically the exact same thing. Okay, let's use different numbers. So for A and B, let's use some different numbers. Somebody give me another number. Sure, go ahead. 8. All right, so for A, for A, we're going to use an 8, and then somebody give me a number for B. Gage? 7. All right. So that means if we go over to the example, we're going to fill this out. That means that 8 times 7 equals, and then we're going to flip flop the order, 7 times 8. And then let's work out both sides. 8 times 7. Anybody want to tell me what it is? Go for it, Cameron.
56.
56. All right. So 56 equals, and then of course, 7 times 8, we know that also equals 56. So the commutative property of multiplication, basically, again, it just means the order doesn't matter. Okay. All right, so now we've got the associative property of addition, okay? And we've got A, B, and C that we need a number for. So somebody give me a number for A. Somebody I haven't heard from. Come on, y'all got to talk. Yes.
9.
9. All right, so in this case, A is going to be 9. Somebody give me one for B that hasn't talked yet.
3.
3. All right, and someone give me one for C. Somebody in this row. Y'all are being too quiet. Zoe? 10. All right. These are the easy questions. All right. So what is the associative property mean? Well, if you look at the parentheses tell us what to do first, right? So in the first example, we're going to have the parenthesis 9 plus 3, and then outside of the parentheses plus 10. And then on the second side of the equal sign, we're just going to move the parentheses. So A is still going to be worth 9 plus, and then the parentheses this time are going to be around the B and the C. So 3 plus 10. Okay. Now parentheses says, what do we work first? So inside, so 9 plus 3 is 12. And then we do that plus 10, and 12 plus 10 is 22. So let's check the other side. Inside the parentheses, so we're going to leave that 9 plus alone. Inside the parentheses, we have 3 plus 10. 3 plus 10 is 13. And then 9 plus 13 is, in fact, 22. So with the associative property, and if you kind of think about it just as a memory trick, is who you associate with, right? Who's your group of friends? Who do you associate with? So if you group A and B and then add C, it's the same as if you group B and C and then add A. Can somebody grab the door for me? So the associative property of addition says that if you associate A and B and then add C, it's the same as if you associate B and C and then add A. Okay. All right. So the next thing we're going to look at is the associative property of multiplication. And it basically is the same as addition, which that makes it kind of nice because we don't have to remember a bunch of different stuff. So let's pick A, B, and C numbers. Somebody that hasn't talked. Miley, 4 for A. All right. So let's do 4 and then somebody give me a value for B. Oh, Jada. 6. And then somebody give me a value for C that hasn't talked yet. 2. All right. So we're going to fill in our both sides of our equation with our 4, 6, and 2. So this says, now watch where your parentheses are. Parentheses are around A and B this time. So 4 times 6 times 2 equals, and now look, our parentheses move. So our A still stays a 4. Our parentheses now are around B and C. So 6 times 2. And then let's work out both sides and see if this holds true. Okay, so 4 times 6 is 24 times 2. And 24 times 2 is 48. And let's check our other side. We're going to ignore this 4 for a second. 6 times 2 is 12. Okay, and 4 times 12 is 48. So it checks out. So with the associative property, with addition and multiplication, what it's saying is it doesn't matter who you associate together first, right? A and B, and then not multiply C, or B and C, and then multiply A. Okay, everybody good there? All right, so now we are going to do the additive identity. Okay, so for this one, all we need is a value for A. Somebody that hasn't talked yet, give me a value for A. Yes, sir. 3. All right, so everywhere we see an A, right, we're going to stick a 3, and then let's check it. So we're going to write 3 plus 0 equals 0 plus 3 should equal 3. Okay. So does 3 plus 0 equal 3? It does. Does 0 plus 3 equal 3? It does. And does all that equal 3? It does. So the additive identity is just dealing with adding 0. And basically what that means, and you guys know this, if you add 0 to a number, it doesn't change it, right? So I can add 0 to any number. I'm still going to get that number. Okay. Multiplicative identity, instead of using a 0, we have to use a 1. Makes sense because if we want the number to stay the same, we know in multiplication, we have to multiply it by 1. What happens if we multiply it by 0 in multiplication? Yeah, it turns to 0. So it doesn't work with multiplication. We have to use a 1. All right. Somebody that hasn't talked yet, give me a value for A. Yep. Oh, did you both say 4? Ah, that's awesome. Thank you. You guys are, you planned that, didn't you? You got together before class and you're like, okay, I know this is going to happen. No? Okay. All right. So we're going to stick a 4, a 4, and a 4 in every place where we see an A. So let's see if it holds true. 4 times 1 equals 1 times 4. And we already know that's going to work because of the commutative property, right? We know that both of those are going to be the same. And then they should equal, also A is a 4. So we know that 4 times 1 is 4. 1 times 4 is 4. And of course, they all equal 4. Pretty straightforward. Nothing crazy. And then we've already talked about this, the multiplicative property of 0. This is testing my words here too early this morning. All right, we need one more value of somebody that hasn't talked yet. Give me a value for A. Somebody that hasn't talked yet. Yes, sir. 6. All right. So we're going to put a 6 in place of A. Let's test it out. 6 times 0 equals 0, right? Times 6 again still equals 0. So let's look at it and work it down. 6 times 0 is 0. 0 times 6 is 0. All equals 0. Okay, that's it for the properties. They're not too bad. Okay, commutative property. Okay, think about just order doesn't matter. Okay, associative property. Think about who you associate in your group of friends. Okay, group A, group B added to C is the same as if you group B and C together. So that's an easy way to kind of keep those two separate, is if you can remember who you associate with is your group of friends. Okay, and then additive property or additive identity, we know we have to add 0 to a number to keep it the same. Multiplicative identity, we have to multiply it by 1 to keep it the same. And then the multiplicative property of 0. We all know that anything times 0 is always 0. Good? That's pretty straightforward on that, isn't it? Okay, now down, you can either scoot down and put more notes on the bottom half of your page, or if you want to switch to line paper right now, you can. I'm going to switch over to this one. And this should look a lot like what your assignment's going to look like. So, which I really like using these as the notes because these look identical to your assignment. And we're going to decide this first half, once is to decide which property we're using. Now, we're only going to do a couple of these, okay? So you do not have to write all of these down in your notes. So we're going to kind of do these two together. So I don't care which one you write down, either addition or multiplication, write one of those examples down because they're both going to be really close to the same, right? So on one of these first two examples, one of them is going to be the addition property and one of them is going to be the multiplication property. But which property are we looking at here? Are we looking at commutative, associative, or the identity properties? What do you guys think? Anybody, even if you've talked once today? Which property is number 1? Yes. Yeah, it's that commutative property of what? Addition, yeah. It's the commutative property. Oops, sorry. And then, of course, we want to say addition with number 1 because it's addition. If you wrote down number 2 as your example, it would be commutative property, and then it would be of multiplication. And I don't care which one you put down in your notes, okay? But you'll notice, right, there's only 2, and order doesn't matter, okay? How about number 5? What's number 5? We've got 9 plus, and then this grouping. And then we've got the grouping a little bit different, but it's all the same numbers. Somebody tell me which property it is for number 5. Yes. Perfect. Yeah. It's the associative property. I always double check my spelling. There we go. Associative property of, and in this case, right, it's addition because all of our signs there are addition. Now, you don't have to write this one down in your notes, but looking at these examples, which one is the associative property of multiplication? Anybody? Yes, Gage? No, associative property means they're grouped together differently. So you're going to have parentheses in your groupings. 8, yeah, thanks, Gabby. 8. 4 times 3 times z is the same as 4 times 3 times z. Okay, just your grouping's a little bit different. All right, how about number 4? Which one is that? Anybody? Which one is number 4? Multiplying times 1 gets itself. Look at your notes. Which one was that, Briley? You can just say multiply. I'm good with that. Yeah, identity. Okay, it keeps its identity. All right, if you multiply any number by 1, that number keeps its identity. And that's how you can remember it's a multiplicative identity. Okay. How about number 6? 67 gets to keep its identity. So which one is that? Anybody? Which identity is number 6? Adding any number times 0, or adding any number plus 0 keeps its identity. Yes. Yeah, it's the additive identity. Okay. I'm going to start abbreviating here. Are we good? And then we know multiplying anything, you don't have to put it in your notes because I think you already have an example of this in your notes, but multiplying any number times 0, it's that multiplicative identity, and then you have to add of 0, okay? Pretty good, pretty easy. All right, the bottom half that we're gonna do, I'll wait to scoot up until I think everybody's with us here. We good? All right, This is just a review from 1.1 and 1.2, okay? So it says simplify each expression, okay? And we know when we're simplifying or when we're evaluating, depending on which way it words it, it's our triangle where we start out wide and we get smaller and smaller and smaller based on PEMDAS to simplify it. So let's do number 9 first. Okay, so I'm going to just kind of write it out to the side so I have plenty of room to work. A times, and then in parentheses, 5 times 7. And when it says to simplify or evaluate, we're just going to use PEMDAS to get our triangle smaller and smaller. As small as we can, because with a variable, we don't know what A is, so it's going to stay in A. So the first thing we do is in the parentheses. So we're going to do 5 times 7. So A stays the A. And 5 times 7 is, anybody know? 35. Now, is this the way we write this? Do we ever write the variable first? Always clean it up and rewrite it like this. What property allows us to do this? That A times 35 is the same as 35 times A. Yeah, the commutative property of multiplication. So this right here is perfectly legal because of our commutative property of multiplication saying order doesn't matter. Okay. Now let's look at something like number 15, because this looks kind of weird. M plus 11 plus 19. Okay, and we want to get it as simplified as possible. Can we add M plus 11 if we don't know what M is? Okay, but what we can do is we can use the associative property of addition to regroup these. And we can add 11 plus 19, right? Because of the associative property of addition, we know that we can group 11 and 19 together, and we can leave M hanging out. Oops, we can leave M hanging out there by itself. And then what's 11 plus 19? Anybody? 30. And that's as simplified as it can get, okay? That's as simplified as it get. Because the associative property, we could regroup it, we could add these two together, and that right here is as simplified as it's going to get. So when there's variables involved, okay, you're not always going to be able to simplify it all the way down. But what about number 19? What's as simplified as we can get this? Does it matter what S is? Anything times this is going to equal what? 0. So it doesn't matter what S is. You can put any number in the world in for S. And because of the multiplicative identity of 0, I'm gonna trip over that word every time I say it. Because of that property of 0, the identity property of 0, it doesn't matter what S is. So we can simplify this all the way down to 0 because we know that anything times 0 is 0. So that would be your final answer. Okay. So with these, you're gonna simplify them as much as you can. This would be a good example here. Which property says, because we don't know what R times 5 is, right? We don't know what R is, but what property says I can regroup these? Somebody tell me. What property says I can do this? Remember when you associate with your group of friends? So it's the associative property of what? Multiplication. You guys are being too shy. Oops, that doesn't help me. Sorry. I just realized what I did. Okay. Can I multiply? This is kind of a trick question because we didn't have an example like this, but 4R doesn't really help me either. Can I multiply 4 times 5? Does any order matter? Can I do 4 times 5 times R? Is that valid? What's 4 times 5? 20, right? 4 times 5 is 20, and then we can multiply it times R or just write it like this. So with multiplication, right, any order is fine. Any order is fair game. Same with addition. So if your 4 and your 5 aren't touching, you can still multiply them together to simplify. Okay. Same thing here. I'm not going to work it, but same thing here, right? I can do 9 times 10. So I'd get 90B. Okay. This one, the times 1, right, doesn't change anything. It's just 72G. That's that identity property. Okay? We good there? Simplifying these? All right, that is all I've got. Let me pause my, or stop my recording. For those of you at home, after you take notes in your 3-ring binder, go ahead and go back to the assignment and click on the load in Kami at the very bottom, and you'll be able to work today's assignment in Kami and then submit it that way. And email me if you have any questions.